Question 32. 1 gram of a moist sample of a mixture of KCl and KClO3 was dissolved in water and made up to 250 milliliter. 25 milliliter of this solution was treated with sulfur dioxide to reduce the chlorate to chloride, and excess sulfur dioxide was removed by boiling. The total chloride was precipitated as silver chloride. The weight of the precipitate was 0.1435 gram. In another experiment, 25 milliliter of the original solution was heated with 30 milliliter of 0.2 N solution of ferrous sulphate, and unreacted ferrous sulphate required 37.5 milliliter of 0.08 N solution of an oxidizing agent for complete oxidation. Calculate the molar ratio of chlorate to chloride in the given mixture. Fe2 plus reacts with ClO3 minus according to the reaction ClO3 minus plus 6Fe2 plus 6H plus forming Cl minus plus 6Fe3 plus 3H2O. Now from this equation it can be seen that the valency factor of chlorate is 6. Now in the second experiment, where chlorate ion is heated with ferrous sulphate, the equivalence of chlorate will be equal to equivalent of ferrous sulphate that took part in the reaction. And equivalent of ferrous sulphate that took part in the reaction will be equivalent of ferrous sulphate present initially, which is equal to normality of ferrous sulphate, that is 0.2 N, into volume of ferrous sulphate in liters, that is 30 divided by 1000 liters, minus equivalence of ferrous sulphate left after the reaction. Now equivalence of ferrous sulphate that is left after the reaction or unreacted ferrous sulphate according to the question required 37.5 milliliter of 0.08 N solution of an oxidizing agent for complete oxidation. Therefore, equivalence of ferrous sulphate that did not take part in the reaction will be equal to the equivalence of the oxidizing agent required for complete oxidation, and that is equal to normality of the oxidizing agent, which is equal to 0.08 N, into volume of the oxidizing agent in liters, that is 37.5 divided by 1000 liters, and this is equal to 3 divided by 1000 equivalents. Therefore, equivalence of chlorate is equal to equivalence of ferrous sulphate that took part in the reaction, and that took part in the reaction, and it is equal to 3 by 1000 equivalents. Therefore, moles of chlorate will be equal to equivalence of chlorate, that is 3 divided by 1000 divided by valency factor of chlorate, that is 6, and this is equal to 0.5 into 10 to the power minus 3 moles. Now in the first part of the experiment, the mixture of potassium chloride and potassium chlorate was treated with sulfur dioxide. Now on treatment with sulfur dioxide, chlorate ion got reduced to chloride ion. The chlorate ion got reduced to chloride ion on treatment with sulfur dioxide. Now after converting the chlorate to chloride, the total chloride was precipitated as silver chloride. Now this total chloride includes the chloride from potassium chloride and the chloride which is obtained from chlorate or potassium chlorate. Now applying principle of atom conservation to chlorine atoms, we can write moles of KCl plus moles of KClO3 is equal to moles of AgCl. Therefore, moles of KCl plus moles of KClO3 is 0.5 into 10 to the power minus 3 moles, and this is equal to moles of AgCl, Moles of AgCl will be equal to weight of AgCl, that is 0.1435 grams, divided by molecular weight of AgCl, that is 143.5, and this is equal to 0.001 moles. From this, moles of KCl is equal to 0.5 into 10 to the power minus 3 moles. Therefore, moles of KCl, or the ratio of moles of KCl to moles of KClO3, is equal to 1:1.